Okay, so for this example, they're asking us, what is the sum of the measures of the exterior angles of a polygon with 16 sides? So what's strange here is they're talking about exterior angles. What do they mean, exterior angles? What they mean, first off, let me just draw it. They mean like if you have like a polygon here with a bunch of sides like that, if you, an exterior angle, if you let any side just go on like that, extend any side, then this angle right here is called an exterior angle, as opposed to this one, which is an interior angle. So how do you find the exterior angle of a polygon? That's kind of weird, huh? And the sum of them, what are they going to all add up to be? That's kind of weird, isn't it? Well, what I've done, here's the notes. I've given you a formula for this. And the exterior angle is, there's the formula for an exterior angle. It's 360 over, and this is for a polygon, 360 over n, where n is the number of sides. Insided. So now this is for a regular polygon, but we'll make it work for this sum here. So 360 over n. So each angle is 360 over n for a perfect. If it was a perfect polygon, perfect, which means regular, we call that a regular. Is the word. A regular really means perfect. All the sides and all the angles equal. Each angle is 360 over n. That's each angle. But notice, what do they want? The sum. So if you add up n angles, each being 360 over n, how's that gonna work? If you add up, think about what this n is. If you add up 3 angles, what if I said, hey, I'm going to add up 3 angles and each one is, I don't know, 10 degrees. What would you do? Well, just 3 times 10, 30 degrees, right? What if I said, okay, I'm going to add up, let's change this, 5 angles, and each one's 10 degrees. It will be 5 times 10, right? So if you're going to add up n angles, then it's n, and each one's 360 over n, then it's n times 360 over n. Does that make sense? If you're going to add up 5 angles, and they're each this, then you multiply by 5. If you're going to add up 7 angles, and they're each this, you multiply by 7. If you add up n angles, and they're each this, you multiply by n. Well, what happens when you multiply that by n? Well, this, do you know about, are you comfortable with fractions? Anytime a whole number is interacting with a fraction, you put this over one, or a whole letter. These cross cancel. It's just going to be 360. The answer is going to be 360. It doesn't actually matter how many sides, because the n actually cancels out. Notice I never did anything with the 16, because the 16 would have been the n. You could plug in the 16 here if you want to. It's just going to cancel out. The answer is just 360. It doesn't matter how many sides. It's always going to be just 360 degrees. Now you might say, yeah, Mr. but that's for a perfect polygon, a regular polygon. Each angle is 360 over n, so multiply by n. How do that would work for any polygon? Well, yeah, that's a more tricky question. I could prove that if you're interested really quick. Why it's going to be more advanced math, though. You'd have to go back to the sum of the interior angles. Remember, we learned you could break this. If you go back... let me go back to this real quick and go back to the formula right here. There we go, and I'll put this back here for you. So I'm gonna prove this real quick, because I don't like to leave anything like random. Even though you don't have to do all this. This isn't necessary, but I want to show you. So this is for any polygon, not perfect. If a polygon has n sides, the sum of the angles is n minus 2 times 1. That's the sum of the interior angles. N minus 2 times 180. So therefore, n minus 2 times 180. So if that's the case, the sum the interior angles is n minus 2 times 180, right? Okay, and each exterior angle, notice an interior and exterior make 180, so each exterior angle equals 180 minus the interior. So this is harder. You don't have to do this. We're done with the problem, but I'm showing you the deeper reason why. Each exterior angle is 180 minus the interior angle, because they make a straight line. That's what an exterior angle means. So, okay, so what does that mean? So that means for each exterior angle, it's going to be 180 minus the interior. So if you have, so each exterior angle is 180 minus each interior. So then if you add up all of them in angles, well then the sum of all in exterior angles is going to be, each time you're going to take the 180 minus the interior. So you're going to take 180 n times minus all in exterior angles. The sum of interior, I should say, angles. Now this is probably confusing. So each exterior is 180 minus each interior. So then if you do the sum of all of them, sum of all in exterior angles, you're going to take 180 in times, right? One for each angle, minus the sum of all in interior angles. So that's going to be 180 in minus the sum. What was the sum? This right here, minus this. I'm going to put the 180 in front, times n minus 2, which is what? This 180 minus 180 will distribute. We'll get 180n minus 180n plus minus 180 right here, times minus 2 is plus 360. These drop out. 360. It's proven. That I proved it's true for any angles, not just perfect angles. But anyway, you don't need to pay attention to all that. That was more fancy math. You can just use the formula 360 over n multiplied by n cancels out 360.